Welcome to Atega Tech Academy. Today we'll continue with our applied electricity video series, and today we'll start with Unit 2. This is our first video on Unit 2, and today we'll be looking at AC circuit networks. So here today our main focus will be how to calculate the RMS value and the average value of the various waveforms we have. We know that we have basically three types of waveforms. That is the square waveform, the triangular waveform, and the sawtooth or half triangle waveform. So without wasting much time, I would like to start our video. So please remember to share the video, like and subscribe. We want to learn how to calculate the average value and the RMS value of the various waveforms. So I want to take the first waveform, which we call the square waveform. So with the square waveform, it looks like this. So you'll be given a waveform that looks like this. This will be um, the maximum value, or the amplitude. So let's say the H is it, and this will be the time. This will be the duration. So when you are given a waveform like this and you are asked to find, let's say, the average value and the RMS value. So we know the formula for average value is the area of the waveform all over the period. And for the period, we know how to identify the period. It's the duration of a signal. So you see that this signal starts from here and it ends here. So this is the period. This would be the period, the time period for this signal. So let's say if we had a value here, like maybe let's say 6. So the total period of this signal would have been 6. Then to calculate the area, we simply use the area of this. So it's the length. To calculate the area, it will be the length times the height. So that's how this is the formula to calculate the area of this waveform. It will be the length. This is the length. It will be the L length times the breadth or the height. So that is how we calculate it. So the length will be from this to this, which is 6, and the height will be the H. So it will be the L by H. And now to calculate the average value, we need to use this formula. It will be area under the waveform. So that is area under the waveform, which is a square waveform here, over the total period, the period here for that waveform. So we started from 0 and we moved to 6. The period that it has covered is 6. Then afterwards, we now need to calculate the RMS value. So to calculate the RMS value of this waveform, there is a formula that I just want you guys to keep in mind. These things are just formula work that you need to keep in mind. So we name it energy of this signal. So energy of any rectangular or square waveform. This is the formula you use. You come and square the height, then you multiply it by the period the waveform is covering. So let's say if the waveform started from 0 here to 6, so this period that is covering, so before it repeats itself, so it's from 0 to 6, so we just come and take the period is covering. That's why I named it as tau over the time. Then after finding this, we just divide this. We know that the RMS value is the square root of that. So we just divide the E signal over the total period. So this is the value of our E signal. So we just do the square root of E signal over the total period. So the total period of the waveform was 6. So we just divide it by the 6 again. So that is how we calculate the average value and RMS value of a square waveform. And to calculate a triangular waveform, this is how a triangular waveform looks like. You see that it will have an amplitude. So we need to find the area under this waveform. So let's say this one, they will give us a time here. Let's say it's from 0 to maybe 8. There will be values. But let us look at this something here. What is the formula for finding the area of a triangle? So we say the formula for finding the area of a triangle is half the base. This is the base. From here to here is the base. Time is the height, and the height is this. So area to find the area of a triangle is the formula half base times height. Then after finding our area of the triangle, we divide it by the period to find our average value. So average value is area under the waveform over the period. So it will be our half base times height all over the period. So the period here is like, let's say 8. So, and we also have to calculate the energy of the triangular wave. So the energy of the triangular wave, we use this formula. So is the height squared times tau. The tau is the period of the waveform. So let's say this one is 8. Then we divide it by 3. So dividing it by 3 will give us the energy of the signal. So after doing that, we now come and bring our formula again. So V RMS is equals to the energy of the signal by the period. It will be the whole of this divided by the period. So let's say the whole of this divided by 8, which is the period. So that is how we calculate the energy of a triangular waveform. And now let us also look at how we calculate the energy of a sawtooth. So this is a sawtooth waveform. So we call this a sawtooth because it looks like, it resembles like the tooth of a saw. Like if you have seen the saw, the one the carpenters use, it resembles it. So this is how it looks like. But when we realize, let's look at this. When you divide this triangle into 2, you get a sawtooth. You see, when we divide this triangular wave into 2, we get a sawtooth. So this one, to also calculate the area, is the same formula as this. So to calculate the area is also half base times height, and to calculate the average value is also the same formula you use. So however you treat a triangular waveform is same as treating it for a sawtooth waveform. They are the same, they have identical formulas. It's just this one, it's just a half of this. Then to also calculate the energy of that signal, we use the same formula, this formula, the height squared times tau. That is the duration of the waveform. You see that this one, the waveform starts here, so it's repeating itself. So let's say this is 8 here, so duration, the period of this waveform, then divided by 3. And to calculate the energy of the signal, the VRMS is the energy of the signal, E signal over the period. So this is how we calculate the RMS value and average value of the various waveforms. So in our next video, I'll be taking a question, then we'll just simply use these formulas to calculate. The long process they showed you in class is how to prove these formulas, but this is just the formulas you need. So you have to keep these formulas in mind, and I know that they are not difficult to memorize. So let us now look at what now we've known how to calculate the RMS value for the various waveforms. Let us now look at why the RMS value is important and why do we need it. So the RMS value, the root mean square value, represents the equivalent value of an alternating quantity. It could be a current or a voltage. So it is important in engineering because it gives us a way to compare AC quantities to DC quantities in terms of their ability to do work or deliver power. So what does this mean in simple man's term? So in a simple man's term, for an AC circuit that an AC signal that fluctuates over time, the RMS value represents the equivalent DC value that will produce the same amount of heat in a resistive load. And for example, let's say if we have an RMS voltage of an AC source which is 230 volt, it means that the AC source delivers the same power to a resistive load as a 230 volt DC source. So this is how this is why we need the RMS value in order to be able to compare it with a DC source. So that is why we need RMS value. Thank you. So thank you very much for watching. This is our first video series on this topic, so please kindly like, share and subscribe. Then the next video series we will be taking examples on how to solve questions on RMS values and for some various waveforms, and I'll be giving you an assignment to try your hands on and leaving the answer in the comment section. So please, thank you, kindly like, share and subscribe.